Hello and welcome back to a new video in my commercial grade C++ video series. In the last video, we implemented the construct of the services. So when I start my application and I instantiate and start a service, what you are going to see is that there was a service thread started and that there was a service thread stopped. Now, what we need to do in this video and following on is we need to now fill this service thread with life. So currently it's just a simple thread. It starts, it stops, it's done. That's not what I want. I want to have a bit of a proper information for the services. So let's go into our basic service and let's start customizing the code a bit. Now, one thing you can see here, service thread started, we had this in logging and then we had while, and we were just sleeping there. And why are we actually stopping? Yeah, we were stopping, of course, because the service was destructed. So this has been done correctly. Okay, so let's now fill this with life and be able to interact with the service. Now, a service, it's actually quite common to have a few callbacks in the service that allow you to interact with it. So you can see that we currently have this as a base class here, so basic service. So it's meant to be a base class, but there is like no virtual function. There's something with like the protected get logger and things like this. But there is nothing really that, it's like really interacting with the service. For that, I want to have a few virtual callbacks that allow a superseding implementation. Kind of like get some notification on what's going on. Currently the constructor is not virtual, so I want to add the virtual here so that we don't run into problems here. Then what I want to do is I want to have a few on callbacks. I'm going to have an on start callback. So this is going to be a void one, virtual void on start. And I think I want to by default just give them some empty body, which I think should be sensible. On start, we're going to have on stop. And what we're going to have is on update. So we're going to have a start function, a stop function, and a update function for the service. And in the update function, I will have something called DT, or we can even call this delta time and completely write it out, because that's basically what it is, the delta time in milliseconds. Now, we want to add some documentation, of course, to that, so to our callbacks. And we're going to have something is called when the service shuts, or let's call this a service. How did I call it? Yeah, start and stop. Okay, is called when the service is started, and this is called when the service should stop. So we have one that is called when it should stop and when it's started, and then we have the update function, ticked function into the service, run in a loop while keep running, and then we have our delta time here. And our delta time is going to be the delta in milliseconds. So that's basically how this goes. Maybe let's not make this one like that. Let's make this a uint. I think 16t should be enough for a delta time. Yeah, no, I don't know. Let's make a 32-bit integer for that one. And yeah, these are now our callbacks. Now, how are these callbacks being incorporated into the thread? So what we're going to have here is the on start. So the on start callback will be called when the thread starts. And then what we are going to have is we have the sleep in here. We're going to have the on update there. And then what I personally just do is I think I just want to maybe just yield here without anything else. And then what I need to do is I need to calculate the delta time, and maybe, what did I do in milliseconds? Maybe let's make this a float so that, I don't know, I think milliseconds are already quite granular. So maybe we're going to use a sleep 4 here and at least make sure that we sleep 1 milliseconds in order for the tick to be sufficient in its resolution. Now what we need to do is we need to have the time. So as a chrono high resolution clock now is going to be the start point, but I think I want to alias the clock here. I think we don't have chrono currently. Now we have chrono, and what I want to do is I want to make a using clock equals to that, so that we have the clock defined here, and then we can just do clock now, and then we say auto last tick is equals to now. Okay, then we have the on update, or actually let's make it like that so that the start does not be taken into account. So we have the last tick, and then I will have the auto now equals clock now, and then we have to do, and then we can basically on update say it's now minus last tick, and there should be the count attribute to get the milliseconds out of that. I'm not sure what this is. Maybe we should have an std chrono duration cast to std chrono milliseconds here, so that we can cast this before we do that. So that we get the real like duration out of that. And then what we do is last tick equals now here after the update call in order to manage that. And I think this one should work fine. Maybe there's a problem still there. I'm not sure about that. Okay, so but it worked out. So basically what we can now do is we can now do the callbacks. And I can say like void on start override, and I'm just going to say get logger info service started, and I do a on update with the uint 32t delta t for the data time, and then I can say get logger info tick off milliseconds. Then we do a delta t here so that we have the milliseconds, and then we have the on stop, and on stop I basically say get logger info service stopped. So that's the idea of these callbacks. They work like that. So let's run the code and see if we get something. Service thread started and service thread stopped. That's interesting because we did not get an update, probably because I forgot the override keyword, I think. So that we can override that. No? Why do I not get a call into that one? Started, service thread stopped. I don't get any log message. That's not supposed to be. Interesting. Why do I not get any log message? Let's maybe go into the thread name. Yeah, now it had a problem because I changed the file. Let's go inside here. Virtual void. That's interesting. Why is the virtual function table not propagated? Why do I not follow in that? Hang on. It's kind of not propagating. I have the wrong pointers in there. I don't know why it is though. Let me check that. Okay, I think I fixed the issue. The problem was some weird synchronization stuff that like the order of the destructor and things called in a destructor lead a bit to like undefined behavior. If we are stopping and awaiting explicitly without the destructor, it kind of works because we get the service started, but not the service stopped. We don't get the service stopped because I was just stupid and did not call it actually, because we have the stop here where we set the stop flag true. So in this case, if not stop flag, what I want to do is I want to set it to true, but before this I want to call the onStop callback. Why do I want to call this one from the calling thread? Because the calling stop is quite important. And maybe I think one thing that I would like is we have this onStop that is like with the onStop call and onTerminate. Maybe we want to have a onTerminate callback as well. Called on the actual thread termination, and this is when the service should get stopped. So let's put the onTerminate in here as well. So we have the onStart and then we have the onTerminate, so that we have a bit of more option. So we can say service stopping here, and then we can say service stopped in here in the on terminate callback. So now we have a bit more control, and now we should get all these proper informations. So service thread started, service started in here, then service stopped, and you can actually even see that service stopping is at the top. So the app started, it starts the service and directly stops the service. So service stopping is called directly. Then we have here like service thread started, service started, service stopped, service thread stopped. And yeah, we have this all a bit ordered around. And I think we could get lucky and get one message before another. No, it's quite deterministic on how it happens. I'm here on release. Let's maybe try this on debug though, to see how it goes on debug. Let's wait. Service stopping. Yeah, I think we don't get it somewhere else because of debug. Okay. Now what we need to do is we need to actually implement something in the service. Or actually, before we do that, maybe let's quickly do a std this thread sleep for std chronoliterals. Let's do seconds here. Let's do something like 10 seconds. I think we cannot do it. We really need to make it in the namespace known. Okay, and this thread is also not known, or what? No, it's known. Using namespace chronoliterals, we can delay it for like 10 seconds, and then we should get also the update method. So take off for 16 milliseconds, 15, 16, 15, 16. So we get a lot of information already here, and then boom. Okay, service terminated. So you can see that our service is now also ticked. This is quite good. You can see it all working. The only thing that's a bit different is the service stopping, because you can see it's comes through a different thread, but that's totally fine for me to have these informations coming in like that. All right, so now we have a basic service, and we gave it somebody. And what I want to do directly is I want to directly implement quickly the web service, because the web service is a quite easy one actually. I will have them quickly in here, and we'll quickly take this one because we want to of course have later a proper web service implemented, but I can quickly just include httplib here, and we can quickly implement httplib server. I am doing this without SSL now, so we're going to have a httplib server in here. Okay, so that's the server. Then what we do is we need to configure it. We would configure that one in the constructor. So we could, for example, register a get method on the server. You already know that how this works from my tutorial where I showed how this one works. So this is an httplib request reference, which is actually const. So we have a request here, and then we have an httplib response like this, and then what we can quickly just say is like response dot set content. So we set the content here, which is going to be text HTML, and then we do a header quickly and say it works, basically. So that's how we configure that, and then maybe we can quickly bind the server to a port, which is like, let's say the web port 80 quickly, and we bind it to the whole system. And that's it. Now we just need to implement like these callbacks that we need. We for the HTTP lib, we don't need an on update one. We don't need an on terminate because we don't really care about termination. But what we need is we need to get the stop request to properly stop the server, and we need a start request to properly start the server. Because this one we can say listen after bind, because we already bound the server, so we can listen after bind. We can maybe make write some code here. So if not listen after bind, so there was anything wrong, we can get the logger, and what we can say is we can say error fail to start HTTP server. This could be if there's the port is already used or something like that. And then on the on stop, we need to call stop on the server, because basically what this call does, it's a blocking call. So actually we will never go into our thread loop there if we implement it like that. Yeah, this should be already the web service. I just want to rename this to WWWService, something like that. And yeah, I just now can put the service in here, and then actually let's maybe sleep for 100, or let's do 60 quickly, 60 seconds, and then I stop the web server, and we can just simply check if we now have a web server running. Okay, so you can already see that Windows asks if my application is allowed for a network. I just say allowed. So we get the service thread started message, and it seems like that the web server is listening. So let's open a new window here. Let's go to localhost. It tries to go to HTTPS localhost. I go to HTTP, and well, what we actually get is we get it works. So yeah, we have now a HTTP server running. And this one looks quite ugly, right? Because we want to have a good looking one. So get bootstrap. We can quickly make this one pretty by clicking on reader docs, and we can have the CDN starter here quickly. This one should terminate in any second. We can see that, yeah, it's running for like this is like 5 more seconds. We can quickly see if it also terminates. It should terminate. It's not a feature yet. We don't want to have an application with a lifetime of 60 seconds, but yeah, so the thread stopped. You can see it works. We have exactly 1 minute of runtime, which is exactly what we programmed. Now let's actually define like this one. So let's do a const char, and I'm going to just call this one HTML and quickly make this a raw string. No, it's raw strings are done like that. So I want to quickly just put the HTML content in here just to make this formatted a bit nice, because HTML in C++ is actually quite feasible. I think we're probably going to have it in at some point as well. And we can quickly pull in the bootstrap sample code in here, and then you can see that I need to say that I really hate not pretty looking web applications, and with pretty I mean bootstrap. Yeah, okay, it's not nice. We need to have a dark mode. Dark mode. How it works? Enable dark mode. Database theme dark. That's actually what we want. Where did they put it? They put it in the HTML tag. Yeah. So let's rerun the application, and you will see that we get a proper dark mode bootstrap. Yay, there we go. That's how you can build simple web applications in C++ in a service oriented architecture. And the nice thing is we don't really have a service manager here, but that's the next thing that we're going to code. But basically the idea is that you can like split your application. Currently you cannot split it because, well, you can see we only have one service and it's running forever, but we're going to fix that. And yeah, but we have a bit of like meaningful stuff already running. And what we're later going to do is, of course, write more services, and every like part of the application will be its own service. And yeah, then we're going to implement also mechanisms to communicate between these services, of course, so that we can send messages around and things like that. So yeah, that we actually have like a bit of a communication between the subsystems. And this is the whole idea of that, writing a business grade application, a commercial grade application that you can ship. All right, so yeah, thanks for watching for today. We got basic service infrastructure ready. Next time we do the service manager. Okay, thank you for watching. See you next time. Bye.